beams and columns, what is their function in the structure, how do we place them, and their structural importance. Just an introductory lecture because you haven't gone through the technical part of it. So it's just very basic stuff. Okay, so when we say structure or a structural frame, that is the skeleton of a building. Meaning what? You know the skeleton, the skeleton of the body, which is made up of bones. So these bones basically carry the load of your body and they help you move from one place to the other, right? The same is the concept with the building skeleton as well, or the structural frame of the building as well, that it carries the load of the building. Okay, the frame or the elements which carry the load of the building. We call it a structural frame or the skeleton of the building. So in that skeleton, in that frame, the key elements are columns and beams. Perhaps the most important elements are columns and beams. The other one I can think of as the footing, the foundation. Okay, but above the ground level, these are the two members which are the most important ones. So these members, columns and beams, they ensure that the building is safe and it is stable. So it does not fall and it does not move around. Okay, so they provide the strength and the stability to the building. Okay, first of all, what are columns? We have discussed it earlier as well. Columns are vertical elements. Okay, so in the load bearing frame of the building, the vertical elements are called the columns. So the purpose of the column is to get the load from the building, get the load from the slab or the beam. So columns can take the load from the slab directly, or they may take it from the beam. Both are possible. You may have a beam resting on the column, or you may have a slab resting on the column. Okay, both are possible. But the main function is that the column will take the load from one of these and it will transfer it to the foundation. Okay. Now there are two types of forces in structures. One is called the tensile force, the other one is called the compressive force. I will see if I can make it over here. Okay, so for example, you have a member like this. Okay, and I am pushing this member inwards. Okay, so this member is being pushed inwards. So this is a compressive force. Okay, so the member is under compressive force. If the member is like this and I'm pulling it outwards, so the arrow is showing my forces. The arrows are showing my forces. So this is my member and this is how I'm applying the force. Okay, so I'm pulling the member outwards. So this is called as a tensile force. So the first one is compressive, the second one is tensile. Now if you look at the column, it's like this, and the load is coming from the top. Okay, so you can see that it is pushing the member inwards. Okay, the load which is coming from the top towards the column, it is pushing the column inwards. So the force is applied towards the inside of the column. So this is why we call it the compressive force. Okay, so the column is under compressive force because the load will usually go downwards. So in a vertical member, downwards means you are pushing the member inwards. The column can be made up of different elements. We have RCC, steel or wood. RCC stands for steel and wood, you know, steel, wood is wood. RCC means reinforced concrete column. RCC is reinforced concrete column. So what does it mean? We have concrete. Okay, you will learn about concrete. Or maybe you already started. And inside concrete, we put steel bars. Okay, in this course, you will be seeing at members which have concrete. We are made of concrete, and inside the concrete we put steel bars. So we call it reinforced reinforced cement concrete. RCC is reinforced cement concrete. So RCC is a combination of concrete and steel both. We have steel and then we have wood. Okay, so these are different materials by which column can be made. We have concrete columns as well, by the way. It's not mentioned here because they are not very common, but concrete column can also be used. Okay, you can classify columns according to different methods. So there are different methods of classifying the column. There are different methods to specify the shape of the column. The first thing is according to their shape. Okay, shape of the cross section, because I already told you all of them are vertical. Okay, all of them are vertical. So they are basically, if you look at it from the side, then all of them are rectangles. Okay, or something like this. Okay, but when you cut the section from the top, you may see different shapes. So this is one way of classifying the column. So the column can be rectangular, square. You can see circular as well. There's circular column. There's L-shaped column. There is T-shaped column. Okay. There is this one as well with a plus sign. Okay. So it can be according to the shape of the column. The column can also be classified according to the reinforcement you are using inside the column. Okay, so that means that it is only for the RCC material, reinforced cement concrete. So you can have tight column, spiral column, or composite. Okay, so this one, the first one is a tight column. So tight column means, now I'm showing you, or they've already shown it here. So I have steel bars going like this from top to bottom, vertical steel bars in the column, and these steel bars are tied with each other. You can see it here. They are tied with each other. So there is a ring which ties the steel bars which are going from top to bottom. So this is the profile, and this is the section of the column. This is the elevation of the column. This is the section of the column. Okay, so in the profile you see the vertical bars, and in the section you see the vertical bars are tied with each other with a ring. Okay, so this is called the tied column. Then we have the spiral column, in which again we have bars, vertical bars. You can see the vertical bars over here. Okay, but these vertical bars are not tied with a ring at every level. So the ring is going like this, zigzag. Okay, so it starts from here, goes there, then there, then there, then there. So load transfer is slightly different. Okay, so load is transferring from one level to the other level to the other level. Okay, so the ring is not a straight ring. Okay, it's going like this. It's going like this. Okay, so this is called the spiral column. This shape is called the spiral column. It's going from the top to the bottom. Okay, so the bars are going top to bottom, and the ring is also going top to bottom. Okay, and the composite, obviously, then you have some rings and you have some spiral. Okay, you have some rings like this. Okay, at each level, and then you have some spiral as well. So this is what we call as composite. Okay, so this is based on how you are using or how you are tying the steel inside the column. Okay, then we have type according to how the loading is coming. Okay, now if the load is coming at the center of the column, this one, so you can see the load is at the center of the column. So this is called as axially loaded. So the column is loaded at the axis. This is how we get the word axial, because the load is at the axis of the column. Okay, the central axis of the column. So this is axially loaded. And then if the load is away from the center, then we call it eccentrically loaded. Okay, eccentric means that it is away from the center. It's away from the central axis of the column. Okay, so axially loaded means the load is at the center. Eccentric means the load is away from the center. So these are some common methods of defining the types of column according to shape, according to the steel and according to the position of the load. Okay, before I move forward, anybody have any questions? Does anybody have any question? Okay. Like I said, you can stop me whenever you have the question. Okay. Then we move on to beams. Okay, the second important element of the structure of the building. This is horizontal element. So normally it is horizontal. It transfers the load from the slab to the column. Okay, so the position of the beam is fixed. I told you column can be directly under the slab or it can be under the beam. But in terms of beam, it's always between the slab and the column. Okay, so beam is a connection between the slab and the column. Okay, beam resists bending and shear force. Now the beam is like this. Like I said, it's a horizontal member, right? Okay, and the load is coming like this. Okay, so now you can see when the load is coming from the top, it will bend the beam, right? It will try to bend the beam. Okay, so this is called bending. Okay, and which is happening at the whole beam. Okay, so the load is trying to bend the beam. Another thing which the load can do is it may crack the beam from here, direct, not the entire beam, but the point itself. So bending is in the shape of the beam and the shear, this is called as shear. This thing is called as shear. Okay, so bending is the twisting of the entire beam and shear is the cutting of the force at one point of the beam. Okay, so bending and shear. So again, you have a horizontal member, the load is coming from the top, from the slab, and it is trying to uh, uh, twist the beam, okay, bend the beam, and it also trying to go through the beam, okay, crack through the beam. So when it is trying to twist the beam, we call it bending. Okay, when it is going through the beam, we call it shear. Okay, so these are the forces that are acting on the beam. And again, beam can be made of RCC, steel, or wood. Okay, so I told you RCC is reinforced cement concrete, concrete plus steel, steel and wood. Now, because of these forces, bending and shear, we do not use. It's very, very rare that you see a concrete beam, only concrete. Okay, because concrete is not good with bending and so on. Okay, so we have RCC, steel or wood. Okay, because of the type of force we have. A column, the force can be taken by concrete as well because compressive only. But in beam, it is much more complicated. So we don't use, we don't prefer to use concrete. Okay, types of beam based upon support. Okay, how the beam is supported. Okay, so you will learn about these things in statics, basically. I don't know if you have already started the course or not, but these are the support. So support means basically where you're putting the column and how the column is connected to the beam. Okay, beam is on the column, right? So beam support is the column. So how do you are placing the column and how you are connecting the column with the beam? Okay, so the first one is cantilever. Okay, this one I'm going from the picture, easier to explain. The first one is cantilever. So you can see column is only on one side. The column is only on one side, and you can see the column is completely surrounding the beam from one side. See this one? The column is completely surrounding the beam from the one side. So this is called cantilever. Okay, column is on one side and it is completely surrounding the beam. That is completely holding the beam from one side. Okay, this is called cantilever. Then you have simply supported where the column is on both ends. Okay. Now there's a difference between this and this. Okay, you can see if you zoom in, you will see the symbols are different. Okay, so this is what we call as a roller. This one is called as a roller. Okay, and this one is called a pin. Okay, a roller and a pin. Okay, so a pin holds the beam from two sides. So it is holding the beam from the bottom and from the side. A roller only holds the beam from the bottom. Okay, so the difference between the roller is here on the right hand side. The difference between the roller and the pin is in how many directions it is holding the beam. Okay, so the roller holds the beam only in vertical direction. The pin holds the beam in vertical and horizontal both. Okay, so you have two columns, one at each end. Okay, one is only vertical, the other one is vertical and horizontal, and we call it simply supported. Okay, simply supported. Then we have overhanging. Okay, overhanging, now you can see here it's the same symbol as a roller. So these are two rollers, but they are not on the sides of the beam. They are somewhere in the middle of the beam. Okay, so you have some part which is overhanging. This is called as overhanging. This part is overhanging. Okay, so you have two supports, two columns, which are only holding the beam in the vertical direction. Okay, then we have a continuous beam, which has more than two supports. Continuous, okay, you can see rollers and pins here, but the main thing is you have more than two supports. The difference between continuous and the others is more than two supports. There are more than two columns holding the beam. More than two columns which are holding the beam. Okay. Then we have fixed ended. Fixed ended means, or fixed support, whatever you want to call it. Fixed ended, fixed support. You have two supports at both ends, and these supports are completely holding the beam. So I talked about cantilever, right? So cantilever, we had one support like this, and it was only at one end. But in fixed ended, you have both ends which are completely held by the support. Completely held means they are held in vertical, horizontal, and the third direction as well. So there is nothing. There is no free direction for the beam. Okay, there is no free direction for the beam at both ends. In cantilever, there is no free direction, but only at one end. Okay, so there in cantilever there's only one support which is at one end, but and it is completely fixing the beam. In fixed end, we have two supports at both ends, and it is completely fixing the beam. Okay, both are completely fixing the beam. Okay, then you have cantilever simply supported. So you have one support which is completely fixed, and you have the other one is roller. Okay, so roller is only holding it in one direction, vertical. The fixed support is holding it in all three directions. Okay, so cantilever simply supported. Okay, so here you can see that only four names are written here. Okay, simply supported is this one. Cantilever is this one fixed support only at one end. Fixed is this one, both ends supported, and continuous means more than two supports. Continuous means more than two supports. Okay, and then we have two extra here, overhanging and cantilever simply supported, which is not mentioned here because they are not very common. So this is based upon how the beam is supported by the columns and how the columns are supporting holding the beam. Okay, one direction, two direction, or all directions. Okay, another method of classifying the beam is according to the section. Okay, so the beam section can be of different shapes, and you can see these shapes over here. The names are written here. Okay, this is called an I beam or an H beam. Okay, this is a C beam. Okay, this one is which one is mentioned here? Okay, but it's a hollow rectangle. Then we have the L beam, we have the T beam. Okay, so according to the shape, there can be other shapes as well. These are not the only. So this one is called the box. Okay, this is the box shape. Okay, so as you can see, the shapes are of many types. You can have even triangle and so on and so forth. Okay, so but the other method of classifying the beam is according to the shape of the cross section. Okay, based on equilibrium condition. Okay, now your building should be in equilibrium, right? Your building should be in equilibrium condition. Okay, so we need to solve equations to make sure the building is in equilibrium. Okay, so these conditions which you solve to make sure the building does not move are called equilibrium conditions. According to this, we have only two types. Okay. Now, I will not go in details because again, I have mentioned that for this type, you will learn in statics course. For this type, you will learn in structural analysis course. Okay, so there are complete courses which should explain these things to you. Okay, but I can tell you this. In the first type, which we call as statically determinate beam, okay, a statically determinate beam, we have some unknowns and some equations. We solve the equations to get the unknowns. Okay, these equations are called equilibrium equations. Okay, these equations are called equilibrium equations. So if the number of unknowns is equal to your equilibrium equations, we call it statically determinate. If the number of unknowns in the structure is more than the number of equilibrium equations, we call it statically indeterminate. Okay, so this is according to the analysis of the beam. These two types are according to the analysis of the beam. If the number of unknowns is equal to the equilibrium equations you have, we call it statically determinate. If the number of unknowns are more than that, we call it statically indeterminate. Okay, and the courses in which you will go through them are mentioned here. Okay, there are other methods of classifying the beams as well according to casting, material, geometry, and so on and so forth. Okay, but these are not very common. The ones which I've discussed are very commonly used. Okay, what is the function of the column and beam in the structure? Before I move on to that, any questions which you have? Are there any questions by anyone? Everything is clear? Okay. So the function of the column is to transfer the vertical load. Okay. So it takes a load, as I said, from the slab. You can see it here in the picture as well. The slab is transferring the load on both sides. Under the slab, I have the beam, and under the beam, I have the column. Okay. So this is the path of the load. Okay. It goes like this from the slab to the beam to the column to the foundation. Okay. You may remove the beam as well, as I've already mentioned. Okay. So the beam is providing support to the slab, and then it transfers the load to the column. Okay. Some guidelines for placing the columns. Okay. Columns should be vertically aligned at all floors. Okay, so you have a building which has maybe 3 floors. Okay, so now you cannot do, okay, I will make a column here, and the second floor I will make the column here. Okay, this will create many problems for you. Okay, if you are going to use a column, it should go from the bottom to the top. Okay, the column should go from the bottom to the top. Okay, second thing is place the column. These are usual practices. Okay, they can be exceptions. Okay, they can be exceptions, but these are the some of the common rules. Okay, place the column at the corners of the building. Okay, this is very important. Placing the columns at the corners of the building is very important. Okay, so place the columns at the corner of the building and at wall intersections. Also place them at wall intersections. Okay, this is usual practice. Okay, but I will show you some exceptions as well when we are doing the exercise, which is our next activity. Okay, try to use uniform spacing between the column. So between one column and the next column, if the spacing is 2 meters or 3 meters, try to maintain it for the next column as well. Try. Obviously, it is not possible. Okay, it is not possible to have all the columns at the same spacing. Okay, but we try to maintain the spacing as much as possible. Okay, avoid large cantilevers. Okay, avoid large cantilevers. What do we mean by cantilevers? What is the cantilever? This is the cantilever. having support only at one end. Large cantilever means that this length is very long. This length is very long. Okay, so small cantilevers can still be allowed, but you have a cantilever, for example, you have a support, you have a column, and after the column, there's a length of 6 meters without any column. So this is the end of the building. Okay, you have the end, you see the balconies, for example, you have the gallery. Okay, so this is my building. Okay, and I have a gallery here. So usually under the gallery, you will not see the column. Okay, because it will block the entrance. Okay, so you will not see the column here. Okay, but how long is this gallery? If it is like 1 meter or 0.5 meter, it's fine. Okay, this is a cantilever because you have a column only at one end, the support only at one end, but the part which is hanging is very small. Okay, this part is very small, so this is allowed. But if this is not a gallery, this is, for example, a walkway, okay, or a bridge which is going to the other building, okay, like what we have in S41. So now if you don't place, so this is going like this, long and long. Now if you don't put a column here, this becomes a large cantilever. Okay, now this is dangerous. Without this column, if I don't put this column over here, if there's no column over here, there's a big part of the beam and the slab which is hanging. So this is very risky, and it will make the design complicated. Okay, so we avoid unsupported parts of the slab or the beam which are very long. So place the column wherever you have a long unsupported part. Okay, you should try to place the column over there. Okay, so this is what they are saying here. Avoid large cantilevers. So if you have a small part here, no problem. We can do it without the column. But if this part is very long, then we need a column, additional column further along the member. Okay, prefer symmetrical layout. This is same as this one. If you keep the spacing same, your layout will be symmetrical. Okay, your layout will be symmetrical. I will show you one in the exercise what that we will do after this. Okay, so try to maintain the spacing throughout the building and try to maintain symmetrical layout. Symmetrical also means try to maintain the spacing in both directions. Okay, so maintain one direction and maintain the other direction as well. So it will look like a grid. It will look like a grid. This is very preferable. All these things are preferable. Okay, we try to do them as much as possible. Okay, but you will see many cases. Now, if you start looking at buildings around you, especially in mosques, in masjid, and in malls, big malls, you will see that some of these things are not maintained because they need large spaces. Okay, they need large open spaces. They don't want to see columns everywhere after 2-3 meters. It will block everything. Okay, people will not able to move around, and they have shelves, and they have all these things. So especially in these big buildings, you will see that some of these rules are not applied. This is because of the function of the building. Okay, but we try to maintain them as much as possible. Okay, beam placement. Again, some guidelines. Between the columns, there should be a beam. Between the columns, there should be a beam. So if you have two columns, connect them with a beam so that the load is distributed. Okay, if you don't connect it with a beam, the column will take the entire load directly. Okay, and if the load is greater on one side, it will only affect one column. All of it will go on one column. So you have, for example, this slab. Okay, so this is my slab. I have a column here and I have a column here. Okay, now if I don't connect it with the beam, okay, so if there's a beam, even if I put more load here, the load will be transferred because of the beam to the other column as well. But without the beam, if I don't have the beam, okay, what will happen? If I have more load here, it will not go to the other column. So if something is not planned, the load is not equally distributed, it will start damaging one column more than the other. Okay, so beam will make sure the load is distributed. Okay, there's not very high load on one column and not very low load on the other column. Very low and very high is also a problem. Even the column is strong, but the load is not equally distributed, it can create the building cracks in the building. Okay, so we try to avoid it. Okay, so wherever you have two columns, we try to connect them with a beam. Avoid interrupting openings. Okay, opening means doors and windows. Okay, these are the openings, doors and windows. So you have to design the beam according to at what height the door and window are. Okay, like how much space you are having on top of the door and window. So for example, you have a big door. Okay, like again going back to the example of the malls and so on. So they have very high doors, so it may go up to the roof. So there's no place to put the beam there. Okay, so if you put the beam, then you have to block the door. Okay, the same thing with the windows as well. So if you put the beam there, then you will block the window. So we try to avoid it. Okay, so if there is something like this, we cannot place the beam there, or if you are placing the beam, then it has to be shorter so it can fit in the available space you have on the top. Okay, so you have, for example, this is my wall. Okay, and I have door up to here. Okay, so if there's enough space for the beam over here, no problem. Okay, but if I have a big door, okay, so this whole thing is the door, then there's no space for the beam here. Okay, so this is what we have to keep in mind. And again, they have given us a ratio depth to span. Span means the length of the beam, the length of the beam. Okay, so this is my beam, horizontal. Okay, this is the span, and this is the depth. Okay, L and D. Okay, so they are saying D by L ratio should not go more than 1:12. Again, it's just a guideline. Okay, these are not fixed numbers, but for this stage, we can use them. Okay, later on you will do some detailed analysis to how to find out the depth of the beam and the steel in the beam and so on and so forth. For the time being, we will say that okay, we should not exceed D upon L, which is more than 1:12. Okay, so if D is 1 meter, then L cannot be more than 12 meters. This is what they are saying. If D is 1 meter, L cannot be more than 12 meters. Okay. Place the beam under the edge of the slab and walls. Okay. Wherever you have the edge of the slab, the edge of the building basically, or the corners of the building, then we should have a beam over there. Okay. Use secondary beams wherever is required. Okay. Now there is primary beam, there's secondary beam. Okay. Primary beam is this one. This is the primary beam. A beam which goes from column to column is a primary beam. Okay, the beam which goes from column to column is a primary beam. Okay, so at both ends we have the column, or it is connected with the column. Okay, not any other beam. A secondary beam is connected to another beam. Why is that? I will show you with the example. Okay, I will show you with the example. So a secondary beam is connected to another beam. Okay, or is connected to another to the slab. Okay, so the primary beam connects to the column. The secondary beam does not connect to the column. It may connect to another beam or the slab. Okay, this is the difference between primary and secondary. Okay, the common mistakes which we have, okay, which I already mentioned before. Misaligned column across floors. Okay, this where was it? This one, this thing. Okay, this thing. This is the misaligned column. Okay, on the ground floor the column is here, on the second floor the column is here. Okay, so this is misalignment of the column. We should avoid it. Okay, column should go from the ground to the top floor in the same line, in the same vertical axis. Okay, excessive spacing, again something which I mentioned over where is it, this one. Okay, so avoid excessive spacing, and this one as well, it's mentioned here as well. Okay, typical spacing is between this. So avoid having a spacing, especially more than 3 or 6 meters, becomes very large. Okay, ignore architectural clashes. Architecture, what architects are telling us, the window should be where, the door should be where, what will be the height of the building, what will be the height of each floor, okay, what type of roof they want to provide, will they provide a straight roof or a dome or what, okay. So avoid going against what the architects have designed. So architects design the shape of the building. Okay, so try to follow the same shape as you are providing your columns and beams. Okay, so architect says that my building will look like a rectangle, and you say no, it should look like a circle. Okay, so try to avoid that. Okay, try to avoid beam clashes with MEP services. What is MEP? Mechanical, electrical, plumbing. MEP stands for mechanical, electrical, plumbing. Okay, so beams, for example, you have in the building, you will have AC, you will have lights, you will have fans, you will have water pipelines, and so on and so forth. Okay, to pass these things through beams and columns is very difficult. Okay, it has extra cost, and then if you drill through the beam and column, it may weaken the building. It may weaken the building. It will make your building or the structure weak, because now you are putting the hole through the structure. So try to avoid it as much as possible, especially big clashes. For example, AC systems, they require very large large installments, large installations. Okay, so if your beam is clashing with the AC pipeline or the AC duct, then it's not possible to work with both of them. Okay, a wire or something like this we can work. Okay, we may do a small drill and we can work, but if you have something as large as a water sewage line or the AC duct, then it's not possible at all. So when you're designing the building, you have to keep in mind from where the ducts will go, and the cables will go, and where will be the water pipeline, and so on and so forth. Okay, so you have to keep in mind. Ignoring deflection criteria. Deflection meaning uh, moving from its position. Deflection means moving from the initial position. Okay, so this is also you haven't studied it. This will be in the structure analysis course. Okay, so even if you started statics now, you haven't studied what we mean by deflection. But deflection means moving from the initial position. So every part of the building, when it is loaded, it moves slightly. We cannot feel it, but it moves slightly from the initial position because of the load. Okay, so this movement, if it is too much, then you start to see the cracks in the building. Okay, you start to see the cracks in the building, and in some cases it can be more than that. Okay, more than a crack. The whole thing may fall down. Okay, so ignoring deflection criteria, that your building looks fine, but now and it is basically because of spacing or because of the size of the members. Okay, so when you're designing, you have to keep in mind that the deflection should not be too much, otherwise you will have a disaster. Okay, this is a plan of a building. Okay, this has columns and beams both. You can see columns and beams here. Okay, can you identify any problems? Any what we have discussed up till now? Do you see any problems in this design? Any problem with the placement of the column or the beams? You can open the mic, I believe. Yes. Do you see any problem with the placement of the beam and the column? These are plinth beam, basically. These are at the floor level, but the same. Yes, anyone. This is basically, by the way, this is part of your assignment. You have to place the columns yourself. So this is part of your assignment. So I'm trying to prepare you for that. Yes, anyone? Do you see any problem with this plan?
Doctor,
Yeah,
I think there are one more column in the B section.
this one, right?
Yeah,
Yeah. So you can see this column is basically destroying the symmetry. Okay, it's just one column, which is not here and not here as well. Okay, and so there's only one column here. Okay, and it's not evenly spaced as well. Okay,
also,
if you
Doctor, I have one question.
yeah.
Between section D and E, if I
Mm.
put the more extra column in the bathroom, that's it will
Which
be
one?
okay or not?
C and D?
Between D, E, and the
D,
right
E.
one.
Yeah,
Yeah, what if happen if I put the more extra column
there.
here? Yeah,
We don't need to, by the way. This is very small spacing. You can do it without the column as well.
it have to be large space.
Yeah, it should be. Otherwise, you can place a column, but it's a waste of money. You can do it. You can do it.
Maybe the owner of the house they want also extra.
Sorry.
You will save waste of money, but I think it will be more stronger
See, you
for the
have to.
buildings.
This is what I said. We are just looking at the guidelines for now. Later on, you will see how to design the column, and you will see how much money goes in there. Okay, so to do the construction of the column. Okay, so yeah, we want to make the building stronger, but the strength of the building should be of any use. Okay, so I want to make it stronger, but for what? Okay, even if I keep if I make 4 columns, 5 columns, 10 columns extra, it will make the building stronger, but the use of the building will remain the same. When you put extra columns and make it more stronger, the use of the building will not change. The client or the customer will not say, okay, now you make my building stronger, so I will ask my the entire society to come and live with this building. No, it will only be his family. Okay, so you have to look at the purpose of the building. You have to look at the purpose of the building. Does the building need so much strength? Okay, so you have to justify the money with the need. So you cannot say, okay, I will put more columns, I will make your beam strong, I will make your building stronger, but it will cost you 20,000 BD extra. They will say, no, let it be as it is. We are only like a family of 4 or 5 people. We don't need a very strong building. Okay, we don't have so many people. So it depends upon the use of the building. Okay, it depends upon the use of the building. Okay,
Good, doctor.
but you
Thank
are
you.
right about this column. This column is not symmetrically placed and it's only at one end of the building. Okay, so we can remove it and keep the arrangement same as these columns, the other grids. Okay, and this can be done. Yes, any other question? Yeah, access B, yes. Okay, any other comment or question from anyone? Fine, everybody? Okay, so again, for the assignment, if you can prepare your own column, you can mark the columns on your drawing and you can show it to me first. I can maybe guide you. Okay, but keep in mind, all of you may not have the same design. All of you may not have the same placement of the column. Okay, so which is fine, completely fine. Okay, one of you thinks that as there's a spacing of 7 meters and one column is enough, fine. Another one thinks, no, the spacing 7 meters is very high. I'll put a column in the middle. It's fine. Okay, it's fine. Right now, we don't have any, we don't know the cost. We don't know the purpose of the building. Okay, so the purpose of giving you an open assignment that you can place your own columns is to have your ideas. You can have a taste of how do we place the column. Okay, and that everybody may get a different design. Okay, if everybody gets the same design, then I will be curious. Okay, everybody may lose like 1 or 2 marks because everything is the same. Okay, so I want to see the effort. Okay, that you took the effort and you had something in your mind and you use it to place the columns. Okay, so in the end, before we move on to the drawing itself, uh, uh, three things you have to keep in mind. Proper column and beam layout, the placement of columns and beams properly will make your building stronger and stable. It will make your building stronger and stable. If you miss the alignment of the beam and the column, it will make the building weak and you may see cracks and deflections and so on and so forth. When you are developing your beam and column layout, you may have to consult with the architect of the building and the people who are designing the mechanical, electrical, and plumbing systems. Okay, because I already told you there are some systems, if you let them pass through the structural members, either it is not possible or it will destroy the structure of the building. And you have to follow building codes and guidelines. Okay, so guidelines are given uh, in Bahrain code as well. Bahrain follows the Ministry of Housing. They follow a code, okay, and they give you standards. For example, the height of the building. Okay, so a maximum height of 1 floor and how many floors you can have in certain areas. Okay, so these guidelines are given. Okay, how much placement of the steel inside the beams, how much depth of the beam for minimum, maximum. So these guidelines are given. Okay, so before you start your design in the real life, obviously, in the real life, you must know about these guidelines. Even for your assignment, you want to go and search about Bahrain housing, the building construction guidelines, have a look, no problem. Okay, there's no problem with that. Okay. Yes, you will put the axis. You will put the axis. Okay. We call them the grid lines, if you remember. Okay. We call them the grid lines. Okay. The grid lines, not the axis, the grid lines. Okay. Like I showed you in the example here as well. And if you go back to the previous drawings, you will see the grid lines. Okay. So the axis meaning the grid lines. Okay. So you have to put the grid lines. Yes. Okay. So let me first of all share the file on which we will be working. And it's a very simple design, okay, for today. Later on, we will see something which is more interesting. I believe it was this one. Just give me a minute so I see I send you the right file. It was not this one. This one, I believe. You may already have it, by the way. This one, yeah. You may already have it. Okay. Okay, this one. I'll send it. Okay, this is the same file on which we worked in the last lecture, on which we started working in the last lecture. Okay. So let me show what we are doing. Okay. Okay, so this is the file, and I'm trying to see the file on which I did the layout for the beams. Yeah, this one. Okay. Okay, this is what we are trying to do. Okay, but I'll start from here. Okay, so we have this file. I just sent it to you now. Now in this file, the first thing you can see is we don't have any columns. Okay, we did the columns last time, by the way. Okay, we did the columns last time, and the columns are at the intersection of these grid lines. Okay, the columns are at the intersection of these grid lines. Okay, first thing I will do is I will create a layer for the columns. Okay, I will create a layer for the columns. I was doing it with the layer of walls last time. Okay, so let us pick a color for the layer. What do we have? Green, maybe. We didn't use green. Okay, fine. Green. Okay, so I've created a layer for the column. I'll create another layer for the beam. Okay, beam. My beam layer, I'll make it this one, and I will make it hidden. Okay, hidden. Why it is hidden? Because your beam plan is normally at the slab level. You cut the plan at the slab level. So beam is under the slab. So it looks like a hidden line. Okay, the beam is under the slab, so it looks like a hidden line. Okay, when you are looking at the layout, okay, you are looking at the layout, so you cut the section from the middle of the slab. Okay, so beam is under the slab, so it looks like a hidden line. Okay, so that's why the beam layer type is hidden. Okay, so I added two layers, one for the column, one for the beam. Okay, for the column I made the color green. For the beam I have made the color blue, and I have made it a hidden line. Okay, colors are your choice. Okay, colors are your choice, so don't worry about them. Okay, now my column was the one which I made last time, or I can check it here as well. I believe it is 200 by 200 meters. Okay, so I'll make a column of 200 by 200 meters. Okay, sorry, millimeters. 200 by 200 millimeters. Okay, so first of all, I select the layer for column. Okay, make a rectangle. 200 millimeters is 0.2, I believe. Rectangle, this one, 0.2, 0.2. Okay, so I have my column. I'll copy it. Okay, my base point. I will take the base point in the middle of the column. Okay, you want to take the base point in the middle of the column. You can go there, make sure your ortho snap is on. You go there and make sure you have the which one, the midpoint on, and you can go there in the settings and you can make sure that you have the geometric center. There are the center and geometric center. Both of them are on, so it will make it easier for you to pick the center of the column. Okay, so I went there, object snap settings, center and geometric center are on. Okay, so hopefully now it will show me the center of the column directly. Okay, so I will select this, copy, and now you see I can see the center. Okay, the geometric center. So I take it from here.
Doctor,
Yes.
you can just repeat the last thing, how to change the settings of the OSNAP for the
Okay.
midpoint?
Yeah. 1 minute. Okay, so I put it at the intersection point now. Okay, how did I do that? I went there. This is the object snap. I went to the arrow. Okay, this arrow. Then object snap settings. It will open this. And you need to make sure that the geometric center is on and the center is on. Okay, these two are on. Okay.
Okay, doctor.
So I have placed one of the column. Now I will place it in the same way on the other axis as well, on the other intersection points as well. So I do this, copy. I take it from the center. I put it at the center of this intersection point of this. Okay, so I placed 3 columns. Now I can select all 3 of them and copy and paste them together because they are, no, not like this, because they are in the same alignment in the other axis. So I will pick 3 of them. Okay, copy from the center, the intersection point. I put it on the other axis. So all 3 of them are put together. Okay, so first of all, I made one column. I put it here at the intersection point of the grid. Okay, so the column center is the intersection point of the 2 grids. Then I copied this column from this to this and this. Then I copied all 3 columns and I pasted them at the intersection point here and down at the intersection point of the third set of axes as well. Okay, so now you can see I have symmetric arrangement. Okay, for the time being, everything is so symmetric, so I don't face any problem in placing the columns. Okay, more columns are symmetric.
But doctor,
No, I missed something. Sorry, I missed something. Yes. It should not be here. It should be at the bottom. Sorry, axis 2. Okay, copy and go inside. Not copy. I'll move it. Come on. I'll move it. Move. Same thing. Intersection point. Okay, so I moved it. Sorry for that.
Doctor,
The columns are at grid 1, 2, and 3. Yes.
Doctor, if the column is more than the wall, it's bigger than the wall, it's okay?
Yeah. Yeah.
Because every building, you can't see the column because it's hiding in the wall.
Yeah, sometimes a wall is too small here. A wall is 0.15.
Okay, for the assignment, is okay to make the column more bigger than wall?
Yeah, we can.
Okay.
Okay.
Also, doctor, for the beam, in the assignment,
Mm.
we put the beam or not necessary?
No, beam is not part of the assignment. Beam is not part of the assignment. Okay. So the columns are placed. Now I will shade the column like we did the hatching. Okay, I'll go there. This is the hatching. No, this is the hatching. Okay, and we make it the solid hatch. Okay, we make it a solid hatch. Okay, when it is done, you can copy the entire hatch as well. Okay, copy from here to the next column. And again, I'm placing it inside the column. Okay, in the center. Okay, you can do it one by one, or you can again select all three of them together. Okay, and then put it in the whole line together. Okay, I'm doing it one by one. Here. And here. Okay, so all my columns are hashed. I have put the columns over there. Okay. Now what I will do is I will get rid of the extra grid lines I had or I made because of the walls. Okay, so these grid lines only have the walls, they don't have the columns. Okay, so I don't need them right now. I'll just get rid of them. Okay, so the grid lines basically which don't have any numbers or any letters. Okay, I'm getting rid of them. Okay, this one. Okay, so I got rid of all these grid lines. Okay, so I have the main grid lines, the A, B, C, and the 1, 2, 3. Let's get rid of this as well. Okay, so I have just the main grid lines. Okay. Now we said that, let me check the, yeah. Okay. So now we will make the beams. Okay. For the beams, what I will do is I will get rid of the walls as well. Okay. Now you can go there, go here, and you can block all the other layers. So I'm blocking them. Okay. I'm blocking all the other layers. I just keep the layers of walls open. Okay. So all other layers are blocked and the wall layer is open. So now I can select it. Okay. And it should get rid of the walls. Okay. Walls were in one layer. So I went there. Okay. I'll redo it for you. Okay. So I had like this. Okay. I went there and I blocked all the other layers. I'm just keeping the layer for wall open. All other layers are blocked. So only the wall layer has unlocked. The others are locked. The other layers are locked. So whatever I do, copy, paste, selection, whatever, it will only happen to the wall layer. Okay. After I do this, I select everything. Okay. I selected everything. Okay. But only my wall layer is unlocked. Okay. So then I delete. So you can see only the wall layer is deleted. Okay. And then you can unlock the other layers as well. What happened to my hatching? My hatching is gone. Okay. Do you have any questions? I will redo the hatching here. I don't know. It shouldn't have gone, but it did. Anyways. Anybody have any questions? After that, we will do the multi-line. Some of you may already know it. We do the multi-line and the thickness of my beam is 0.15. So I will do a multi-line with 0.15 and I will run it across all the columns. I'll run it across all the columns. Let me check something. Yeah, sorry. Okay. Okay. So I will get rid of the walls. Okay, later on. Okay. For the time being, don't do anything. Okay. If you did it, just undo it. Just undo it. Okay. I forgot the secondary beams. Sorry for that. We have the primary beams and the secondary beams. Sorry for missing that. Okay. So I've undone everything. Okay. My walls are here, the grids are here, everything is here. Okay, I will delete them later on, or I will remove them later on. For the time being, it's the same. I just place the columns and the hatching. That's it. Nothing else. Okay, column and the hatching. My hatching is what? Why my hatching is wall? Okay, you make sure your hatching is in the column layer. Okay, make sure your hatching is in the same layer as the column. Okay, this one. Select similar. All hatching are selected. Go there. Column. Okay, make sure your hatching is the same layer as the column. Make sure your hatching is the same layer as the column. Okay. So sorry for my mistake. So we've just placed the column and the hatching. That's it. Don't do anything else. Just place the column and the hatching. That's it. Okay. And make sure the column and the hatching are in the same layer. Make sure the column and the hatching are in the same layer. Okay. Any problem, anybody? Should I go on? Yes, anyone has any problem? Okay, next step is I will draw a multi-line. Okay, I'll draw a multi-line. Okay, multi-line for the beam. So I'll select the beam layer here. Beam, where is it? Beam. Okay, and beam is hidden. Beam layer, the beam type is hidden. The layer type, the line type is hidden. You can see hidden. Okay, so I made the beam layer and the line, the beam type is hidden. Okay, so I will create a multi-line now. ML, multi-line, ML. Okay, this one. I'll put the scale. Scale 0.15. My beam thickness is 0.15. But my column is, let me just check. Okay, no problem. Okay, multi-line, scale 0.15, justification, I will do 0. Okay, 0 means the center. I'll pick the column, the value from the center. Okay, so I'll start drawing the multi-line again from the center. Okay, from the center, multi-line from the center. Okay, so from here up to the last column. Okay, make sure your ortho is on. Have this on. Okay, so from here up to here, up to the center. Okay, then down. Up to here. Then this one up to here. Then go to the top. And to the top. Okay. I'll do it one more time. Okay. Multi-line, scale 0.15. Justification 0. 0.15 is the thickness scale. Okay. And justification means which point I will pick for drawing the multi-line. So I already have the grid line, so I will pick the center. Okay, so that's why justification is 0. Okay, so I'll go there, first column to the center. Remember the center is on. Okay, you can see the intersection point as well. Select the center or the intersection point and we start drawing it on. We run it across all the columns which are on the sides of the building. Okay, from one side to the other side. Okay, and I will have this ortho on, so I can have a straight line. Ortho is on, this one is on. Okay, so now I have a straight line from here, then down. Come on. Okay, I'll go down. Then from here to here. Okay, and then I close it here. Zoom in. Okay. So these are my primary beams. These are my primary beams. Okay. Why they are primary beams? Because they are going from column to column. They are going from column to column. Okay. But they are only on the outside. Okay. They are only on the outside. I need another beam here. Why? Because you can see the span is very long. The span is very long. Okay. So if I don't make a beam here, okay, first of all, there will be two problems. The first problem will be this column and this column and this column is not connected. Okay, so this column will not be connected to anything, any other column. Okay, and the slab load will come directly on this one. Okay, so I will have two problems if I don't create the beam here. Okay, so I need the beam here. Okay, so I will make a beam now. Again, multi-line, scale 0.15, justification 0. Okay, you already set it, it should not change. Okay, what you have already set, it should not change. Okay, so I'll go there, start from here, center. Okay, and go down. To the end. Okay, this is done. I need a horizontal one here as well, again for the sake of symmetry. Again for the sake of symmetry. Okay, so I will go again multi-line. Now you don't need to put the style and scale every time. Whatever you have set, it will remain the same until you put new values. So I don't want any new values. I will just start it. Okay, whatever the previous values are, they are set. Okay, so I'll make a beam here. Okay, these are my primary beams. Why they are primary beams? Because they are going from column to column. They are going from column to column. So all of them are my primary beams. Okay, all of them are my primary beams. Okay, now we can look for, we can see if we need any secondary beam as well. If we need any secondary beam as well. Okay, there are some possible locations for secondary beams. There are some possible locations where you can provide a secondary beam. Okay, one location is this one. Okay, another location is this one. Okay, and this one as well. Okay, but if you give a beam here, then you can see this one and this one is a very small span. Okay, it's a very small span. So it can work without this beam as well. Okay, but this one, you can see this span is almost equally divided. The span is, if I give a beam here, okay, both the spans are almost the same. Okay, so we can have a secondary beam over here and we can have a secondary beam over here. And now you can see why I would call it a secondary beam. Why it's a secondary beam? Because you see it will start from a beam, it will end at another beam. It will start from a beam and end at another beam. Okay, so that's why it could be a secondary beam. Okay, these two could be a secondary beam. It will not be primary. Primary is from column to column. Okay, so let me check, because in the end I will show you. Okay, so this is what I have done here as well, I believe. Yeah, okay, because in the end I just want to make sure that, but these are options. Okay, we are not doing any analysis. Okay, so these are all options. So again, I will go to multi-line, start from the intersection point. Okay, and I will go to the other side. So this is done. Then again, multi-line from here. Okay, and I will go to the other side. Okay, all my beams are done. Okay, as I said, we could have put a beam here, but you can see then the one span is very short, the other one is longer. Okay, but if I don't give the beam, this one, okay, between B and C is the same as between A and B. Okay, this is the point. If I don't give a beam here, the span between A and B is the same between span of B and C. Okay, so this is symmetric. So why should I destroy my symmetry? Okay, and provide a beam here? But this is an option. This is an option. You can provide a beam over here as well. Okay, but I'm not doing it because it will destroy the symmetry. So primary beams column to column, secondary beams, the horizontal extra beams which I put, there are two of them, one here and one here. Okay, now we will start labeling the beams. We start labeling the beams. Okay, before we start labeling the beams, okay, let us do something. Let us put our drawing on one side, the drawing which we want. So remember, it was a plan, and from the plan I have created my beam and column and everything. Okay, so it was a plan. This is how we started. If you remember in the previous classes, the column layout also started in the same way. The footing layout also started in the same way. You have a plan, and from the plan you do everything else. Okay, so I place my beam. Before I start writing the coding, what I will do is I will go there. Okay, and I will uh, block my layer for the walls. Okay, I will block my layer for the walls. Okay, so everything else is available for selection. Only the walls will not be selected. Okay, so I block the layers for the wall. Okay, now I'll come here, copy. Everything is copied. Everything is copied. Okay, I will copy it. Select the base point. Select any point as the base point. I will move it now. Okay, I'm moving it to the side. Okay, so this is so now you can see the walls are gone. The things which I need are here. Okay, the walls are gone. The things which I need are here. What are the things I need? The grid lines, the column, the beams. Okay, three things I need and they are there. Okay, I have the extra grid lines as well, which I kept for making these or looking at the position of the walls. Okay, I don't need them now. Okay, I can get rid of them. So I only have the main grid lines now. Okay, I will do it one more time for you. Okay, don't worry. Go there and okay, so this is what I'm looking at. Okay, I'll do it one more time. Okay, I will do it one more time. So first of all, I go there and I make the wall layer locked. I make the wall layer locked. Okay, then I go there to my plan in which I have created the beam. Okay, so I have the beam and the walls, both of them. I don't need both of them. So what I will do, the wall layer is locked. The wall layer is locked and I will go there. I'll select all of them. Okay, copy, base point, copy them anywhere. Okay, anywhere. Okay, so I've copied them. So everything is copied except the walls. Everything is copied except the walls. If there were doors and windows, I don't need them. I will lock them as well and then copy. Okay, and then I see some extra grid lines here. I will delete them. I just have the main grid lines. Okay, I deleted the extra grid lines. Extra grid lines are deleted. Okay, everybody is here? Any problem up till now? You want me to stop or do something or repeat something? Let me know. The rest is just putting the text. The rest is just putting the text. I'll just show you one or two and then I will leave it to you. Okay. So I'll go there. Okay, now I need to name these beams. Okay, I need to name these beams. Okay, I should name the columns as well. All columns are C1. If you want to name them C1, no problem. All columns have same dimension and they have the same length. Okay, all columns have same dimension, same length. Okay, now the beam is named according to its height, width, and length. Okay, if anything changes, we need a different name. If anything changes, I need a different name. Okay, first of all, I'll go there. I'll select the layer for text, circle and text. Okay, this layer should always already be there. If you want to change it, you want to make, because I'm choosing the same as this one. Okay, but if you want to select a different layer, you want to make a different layer, you go ahead, no problem. Okay, I'm selecting circle and text. Okay, so what I will do is annotate. I'll go to annotate, single line text, come here, I'll make a text. I found an option here which does not ask for many things. Anyways, so I'll just put a text here now. Okay, this is my B1. Okay, it has dimension of 150 by 300 millimeters. Okay, B1 is 150 by 300 millimeters. Now you can see it's very big. Okay, so I will select it, scale. Okay, base point. Okay, I'll make the scale as 0.5. Okay, so it's smaller now. If I want it to be much smaller than that, I can do that. Let us make it smaller than that. Base point. And now the scale is 0.6. Okay, now I will shift it down. Okay, so I can put it properly. Okay, I'll do it one more time. I'll do it one more time. Okay, so everything gone. I go to annotate. First of all, select the layer, circle and text. Okay, then I go to annotate, single line text. If it is not there, you go from the arrow, single line text. Okay, then I go here and I put it like this, straight, and I put the angle 0. Okay, then I will say B1 is 150 by 300 millimeters. Okay, or the dimension should be, okay, obvious. Okay, now the scale is very big. Also, the text is very big. I'll select it, scale. Okay, make the scale. I know it was too big, so I'll make it 0.3. Sorry, base point. I'll select it, scale, base point. Okay, 0.3. Okay, so it's the size which I want. You can see the size, okay, according to your drawing. Make it bigger or smaller, no problem. Okay, now you see this beam. Okay, it's the primary beam, right? It's the primary beam, and this one, the one at the bottom, is also the primary beam. This one and this one and the last one, all of them are primary beams. Okay, and their length is also same. Okay, so beam means column to column. Okay, this whole is not a beam. From one column to another column is a beam. From one column to another column is a beam. Okay, so we go column to column. Okay, we go column to column. Okay, so each column to column is a beam. So this one is from here to here. Okay, so this is my B1. Okay, this one is also same. This one is also same. Okay, so I'll just copy from here to here. And to here. Okay, all beams were same. Now this one, I can check the dimension. Okay, if the dimension is same, I will keep it same. Okay, if my dimension is same, then I will keep the same beam as well. Okay, so from here to here, from here to here, it is 3 meters. Okay, and from here, come on, from here to here, it's also 3 meters. Okay, so all of them can be B1, no problem. Copy from here to this one. This one and this one. Okay, so all B1 have the same cross section and the same length. Okay, all B1 have the same cross section and the same length. Okay, now this one is the same length, but it is a secondary beam. Okay, this one you can see it's not going from column to column. Okay, so I can make it smaller. I can make it smaller. So I will just copy it, but I'll change the dimension. Okay, so I'll copy it here. I'll go inside, double click, so you can change the text. Double click, you can change the text. Okay, 200, because it's a secondary beam. Okay, so now I can copy this from here to here. Again, same length, same cross section. That's why. Here and here. Okay, so these are my secondary beams. Okay, I made them smaller. Why you are okay, this one. Okay, same thing for the other dimension as well, the other direction. Okay, wherever you have same length, same cross section, it will be the same. Okay, so I will now just show you the final product, this one. Okay, this is my final product. Now you can see here the dimension is not exactly 3 by 3 because I did not take it from grid to grid. I took it from the end of the beam. Okay, so that's why. Okay, you will see a small thing here. Okay, it's not 3 because I'm taking it from the outside edge. So the difference is because I'm taking the dimension from the outside edge. Okay, so no problem. You can do it like this as well. But now you can see here, this is 150 by 300. This is also 150 by 300. Okay, but I'm calling this one as B3 and this one as B2. Oh, sorry, B1. Okay, and why? Because of the length. The cross section is same, but the length is not same. This is 3 meters and this is more than 3 meters. Okay, so that's why. And one thing which I did not do here, when you change the beam type, you have to change the beam number as well. Okay, so this one will be B2, not B1. B2, this one will be B2. Okay, so to have the same number, the beam dimension, all 3 dimensions must be same. Okay, so you cannot have a beam which has same different length and the same number. Okay, so the number and when the dimension changes, the number should change, and the dimension is all 3 sides. Okay, so this is what it should look like in the end. You can see the beam numbers, you can see the dimensions grid to grid, and also the outer grids. Okay, from one beam to another beam. Okay, obviously we have intermediate beams, secondary beams as well, so you need to show the dimension for them as well. Okay, so that's why. Okay, and you can see the wall was only up to here, but my beam is going up to here. If you look at the plan, the wall was from C to B, but my beam is going from A to B as well, just for the sake of stability and symmetry. Okay, so wherever we can do it, we will do it. Okay, does anybody have any question? So we finished right on time, and I have recorded it. You can see it later on as well. Okay, so this is the final product we are looking at. Okay, it has the columns, the beams, the grid lines, the dimensions, the beam names, and you can put the column name as well, but all columns are the same. Okay, so you can call them C1. All columns can be C1. Okay, they have the same dimension, 200 by 200. Okay, and obviously the height is also same. Any problem to anyone? Okay. Okay, well, just give me 1 second. I don't know whether I can take the attendance from here. I used to. Let me do something. Okay.